Guys, today we'll be discussing network theorems. So under this, the first very important theorem is the superposition theorem, popularly called SPT. So what do you mean by a superposition theorem here is, so whenever in a linear bilateral network consisting of more than one sources, say for example, I'll just consider a network here, look at here, the network consisting of more than one sources, say E1, and this is the resistance R1, resistance R2 and R3, and the current source I here. So in this network, there are two excitations, that's a input 1 and input 2, and I'll consider the response in the circuit is, say current flows through a resistor R3 is my response. So now as per SPT, look at here, so whenever the network, a linear bilateral network consisting of more than one sources, the response in any of the branch, is an algebraic sum of individual responses, by considering one source acting at a time, The meaning is, you just look at here, the total response is my I, in presence of both the sources E1 and I here. So as per SPT, what we can write here is the net response I is equal to, I'll just consider it is I dash plus I double dash. The meaning here is the I dash is a response when E1 acting alone, and I double dash is it's a response when the current source acting alone. So while making a presence of the sources, say for example, if I am considering only an voltage source acting alone, means the remaining sources, see what could be the remaining sources, say for example, if I have a network like this, multiple sources I will consider. See, I'll just consider, say it is V1, V2, V3, and this is R1, R2, R3, and this is R4, and say this is I amperes. Look at here. So here we have there are three voltage sources, 1, 2 and 3, and one current source. So now if I am considering a V1 acting alone, the remaining all the sources you make it as a 0. So how do you make it as a 0? Now look at here. So the current source you should make it as a 0 ampere. The 0 ampere, it is nothing but an open circuit. Because the current flows through an open circuit terminal is, it is 0 ampere. Means under between these two terminals, say A and B, you should make a current to be 0. So means you should make it as an open circuit. Similarly, if I want to make this other two voltage sources, see V2 and V3 to 0, V2 and V3 to 0 means you should make it as a short circuit. V2 and V3 which is equal to 0 volt means make it as a short circuit. Why short circuit? The reason is because a voltage across a short circuit is 0 volts. So that's what the net response in any of the branch of an electrical network is, it's a sum of the individual responses by considering one source acting at a time. So now let us move into numericals related to an SPT, so you will better understand the significance of the theorem. So now this is a network here. See, this is a network. We have a 6 volt battery a 3 ohm resistance and again 6 ohm resistance here, and this is a 2 ampere current source. The question is to find out what is the current flows through a 6 ohm resistance using an SPT. So, this is an electrical network, given electrical network. We need to find out what is I. The I is question mark. We need to find out using an SPT. So, now first observe here, before solving a electrical network problem using an SPT, first you identify the number of sources here. So, the number of sources here, there are 2 sources. You can just observe there are 2 sources, that is, one is your 6 volt source and the other one is the 2 ampere current source. So, we need to find out what is the response. The response is a current flows through a 6 ohm resistance. The current flows through 6 ohm resistance is the response. We need to find out with the help of SPT. So, now I will just consider the step 1. As I said, the step 1 you consider one source acting at a time. So, now there are 2 sources here. So, I am just considering first source is say 6 volt source acting alone. Now, you make a other source to be 0. So, what is the other source here? So, I is equal to current source, that is a 2 ampere. So, now you make that I is equal to 0 ampere. You just omit the other source. So, means current source is equal to 0 means you need to make it as a open circuit. So, what is the resultant network now? The resultant network is, you can write here, it is plus minus, it is a 6 volt battery and we have a 3 ohm resistance, and this is a 6 ohm resistance, and this is the current we need to find out. So, I will just call it is I dash, because it is a part of the response, because I is what we called a nomenclature, the representation, it is in presence of both the sources. So, now I dash I am just calling in presence of just a 6 volt acting alone. So, the current source you make it as a open circuit. So, this is the open circuit part, that is a current source. So, now you just find out what is I dash here. So, you can use a simple Ohm's law, the Ohm's law, to find out what is I dash here. So, I can write directly the I dash is the battery which you have connected is 6 volt divided by the resistance along with this series path, it is 3 ohm plus 6 ohm, it is a 9 ohm. So, you can write it is 3 plus 6. So, you can write it is 6 divided by 9, 3 2s are and 3 3s are. So, what is the I dash value is, it is 2 by 3 amperes. So, this is a response when 6 volt acting alone. This is a response when 6 volt acting alone. So, now the step 2, now you consider the other case. So, what is the other case now? Now, you consider the 2 ampere source acting alone. Step 2, consider a 2 ampere source acting alone. Now, make other voltage source, it is 6 volt source, make it as a short circuit. So, now what is the resultant network is? So, this is a network, a 3 ohm, it is a 6 ohm and we have 2 ampere current source. So, now I will call the response in this branch, we need to find out, I will just call it is a I double dash. So, what is I double dash represents here? It is a response or a current flows through a 6 ohm resistance in presence of a 2 ampere current source, alone. So, now find out what is I double dash here. See, to find out I double dash, look at here. So, I can just use a simple current divider rule here, since because 2 resistors which are connected in parallel with your a 2 ampere current source. So, I can just write using a CDR rule. So, you can write down what is the I double dash. So, I can write it is I double dash is equal to so the main current here it is 2, the main current which is 2 ampere. So, we need to find out what is the current in 6 ohm. So, into the resistance of opposite branch is 3 divided by the total resistance is 3 plus 6. So, you can write it is 6 divided by 9, or you can write 3 2s are 3 3s are. So, you can write I double dash is, which is 2 by 3 amperes. So, now what is the total response? So, you can write by SPT, you can write the total response is, you can write I is equal to, it is I dash plus I double dash, which is equal to, so what is the value we got when 6 volt acting alone? It is 2 by 3, and plus again here it is 2 by 3. So, you can write it is 2 into 2 by 3, which is equal to 4 by 3. So, that is the value of the current I using SPT. So, now let us verify, in a single step, let us verify whether the value of I is what we got using an SPT is a valid or not. So, now to find out that, I will just apply, the main aim is to find out what is the current flows through a 6 ohm resistance. So, I will just apply the KCL at this node. I will just call it is A, the node A, and the node voltage is VA, I will just call. So, you just apply KCL at A, KCL at node A. So, all the leaving currents. So, you can write the all leaving currents here, leaving current, and leaving current, that is algebraic sum of leaving currents at a node is equal to 0, that is your KCL. So, you can write, so VA minus the potential is 6 here divided by 3 plus VA divided by 6, and we wanted a leaving current here, the actual current is entering. So, we wanted a leaving current, so you can write it as a minus 2, the leaving current is minus 2, which is equal to 0. Now, just from this equation try to simplify for VA. So, what is VA you will get now? So, you can just simplify, it is 3 inverse into, you can write it is alpha x minus 6 plus 6 inverse into alpha x. I will just consider VA as a x minus 2. So, that is the equation you will get. So, when I use calculator, so I got the VA value is, it is 6.3157 volts. So, what is I 6 ohm then? So, you can write down I current flows through the 6 ohm resistance is, that is the potential VA divided by the resistance along this path, it is 6 ohm. So, you can write it is 6. So, you can write down 6.3157 divided by 6 divided by 6. So, you get a value it is 1.052 ampere. So, that is your I 6 ohm. So, is it same as 4 divided by 3, that is the answer we got, 4 divided by 3. So, the value of the VA here is, when you calculate from this equation, the VA you will get, it is 8 volts. So, what is the current I? It is VA divided by 6, which is equal to 8 by 6, or you can write it is 4 by 3 amperes, which is same as the answer which we got using. So, that is what the finding out the response in any particular branch using an SPT. So, now let us move on to the next question. So, given it is an electrical network, find out it is a 10 ampere current source, 5 ohm, 4 ohm here, and it is given a load resistance RL, it is given here, and a 2 ohm resistor, 1 ohm plus minus, it is 20 volt, and the value of RL is 7.5 ohm. The question is, find out what is the current flows through the load resistance RL using SPT. That is the question here. So, this is what the RL. So, we need to find out the current flows through load resistance, which is same as IL. That is a question mark here. So, now you just observe the given electrical network. So, there are two sources given here, So, one is a current source of 10 ampere and the voltage source of a 20 volt. So, now as per the SPT, the sum of response in any particular branch is it's a algebraic sum of the individual responses by considering one source at a time. So, now we start with the step number 1. I will consider the 10 ampere current source acting at a time or acting alone. I am just ignoring the 20 volt source. So, ignoring means, so you just make a 20 volt source to be short circuit. Make 20 volt source to be a short circuit. So, what is the resulting network we will get now? So, the resulting network is, it is it's a 10 ampere, a 5 ohm resistance, we have your RL and 4 ohm, and we have this 2 ohm resistor and 1 ohm resistor, and this voltage source you make it as a short circuit. So, now you find out what is the current in the load resistance. I will just call it say I dash now. So, the load resistance value it is given, it is a 7.5 ohm. So, now find out just all the resistors which are connected in parallel combinations, you can just observe here. So, I can just simplify this network. So, these two are connected in parallel, you can write 1 parallel with 2. Again that resultant is connected in series with a 4 ohm resistance. So, what I can do is, so to simplify this, 1 parallel with 2. So, what is the resultant I will get? The 1 parallel with 2, it is 1 inverse plus 2 inverse, the whole inverse. So, you will get a 0.667 ohm, and that resultant combination is in series with a 4 ohm resistance. So, you can write the simplified network. I will just write once again here. So, it is a 10 ampere current source, a 5 ohm resistance, in parallel with that it is 7.5 ohm. So, now you write the resultant is what here? It is 4.667 ohm. So, you can write it is 4.66 ohm, 667. So, just find out what is the current flows in load resistance. So, this is what your I dash. So, now you can just observe now, again do not disturb this particular branch because we wanted to find out what is the current flow through a 7.5 ohm resistor. So, now you can observe here this resistor and this resistor, they are in parallel. You can just simplify now. So, that is a 5 parallel with 4.667, you just simplify. So, what we will get here, the 5 inverse plus 4.667 inverse. So, the answer for this parallel combination is, it is a 2.4138 ohm. So, I will just rewrite once again this network, it is a 10 ampere current source. So, this resultant resistance value is 2.4138 ohm and the RL value which is 7.5 ohm. So, find out what is I now, find out what is I, that is your I dash. So, now you can use a CDR here, the current divider rule, to find out what is I dash. So, the main current is 10 ampere and opposite resistance is 2.4138 divided by the total resistance is 2.4138 plus 7.5. So, just simplify this now. So, you got to answer 2.434 amperes, the value of I dash when a 10 ampere current source acting alone. So, now the step 2, acting alone. So, what is the resultant network? So, now I will just consider it is a 20 volt source. In step 2, consider 20 volt source acting alone, the resultant networks, and the other source is a 10 ampere current source, make it as an open circuit. The resulting network is a current source open circuit. So, 5 ohm resistor, 4 ohm resistor, and we have your load resistance RL, and this is a 2 ohm resistor and 1 ohm along with a 20 volt source. So, now we need to find out what is the load current, that is I will just call it is I double dash. So, I double dash represents the current in a load resistance RL when 20 volt source acting alone. So, now try to simplify this now. This network, what is the current flows through this particular branch. If I know what is the voltage across this particular node voltage, I will just rewrite this network. So, it is 5 ohm, this is my RL here, which is 7.5 ohm, it is 4 ohm, and 2 ohm, it is 1 ohm plus minus a 20 volt source. So, this is a resultant network. Here we wish to find out the voltage value. So, the current flows through the load resistance, it is your I double dash. So, to find out I double dash here, again I will use the nodal method to find out what is I double dash. So, I will just consider the two nodes. So, here the two nodes, one is A, the other one is the B, node B. So, just apply KCL at node A and node B. So, your I double dash is, so this is a node voltage, that is your VA plus minus. So, you can write it is VA divided by your RL, that is 7.5. So, which gives the value of the current I double dash. So, now you apply KCL at node A. So, if you write KCL at node A, so what we can write? So, all living currents. So, you can write a living current, a living current, a living current. So, you can write the first term is, it is VA divided by 5, that is a current flows through 5 ohm resistor, plus the second term, it is a current flows through a load resistance RL is, it is VA divided by 7.5 plus the current flows through the 4 ohm resistance is, it is VA minus VB divided by 4. So, this is what VB, this is a VB. So, you can write it is VA minus VB divided by, it is 2, which is equal to 0. So, now I will just write it in a standard format. So, it is phi inverse, just write it in a linear equation format, so that you can easily solve the equations. So, you can write it is phi inverse plus 7.5 inverse plus 2 inverse into VA minus 2 inverse into VB, which is equal to 0. You can call this equation number 1. So, now you apply KCL at node B, KCL at node B. The KCL at node B, again you can consider all living currents and the living currents. So, current flows through 4 ohm resistance, you can write it is VB minus VA, node voltage VB minus VA divided by 4, plus the current flows through 2 ohm resistance is VB divided by 2, plus the current flows through 1 ohm resistance is VB minus 20 volts. So, VB is rising potential, again plus to minus, it is drop in potential. So, VB minus 20 divided by 1, which is equal to 0. So, now again you write this equation in the standard format. So, we have only one VA term. So, I will just write it is minus 4 inverse into VA. So, VB terms we have 4 inverse plus 2 inverse plus 1 into VB, and what is the constant term here? It is minus 20. If I take it to that side, it will become plus 20. So, now you can just observe there are two linear equations. You can simplify it for VA and VB. Yeah, if you solve this, you know, the value of VA will get it is 7.5 volts and the node voltage VB is 12.5 volts. Now the question is to find out what is I double dash. So from this you can write down I double dash is equal to, so VA we got it is 7.5 divided by, again we have 7.5, so which is equal to 1 ampere. So now you can write by SPT the net response current flows through your RL is, you can write down it is I dash plus I double dash, which is equal to, so what is the value of I dash we got here? The I dash is 2.434 plus I double dash we got it is 1. So the answer is 3.434 amperes. The current flows through a load resistance using an SPT.